This question is called a back titration, and in a back titration you simply have an excess of one of the reagents. So in this case we've got an excess of hydrochloric acid. So in our 50 centimetres cubed of 0.2 moles per dm cubed hydrochloric acid, immediately we can work out the number of moles because we've got our volume and we've got our concentration. So if I write here that the number of moles total is equal to the number of moles of hydrochloric acid that react with the calcium hydroxide, and then added to the moles that are in excess. We know the number of moles in total. How do we know that? Because we've got these two values here. We know the moles in excess because the way we can find that is we can titrate it with sodium hydroxide. And therefore, if we now rearrange this equation, the number of moles in total, so the number of moles that are reacting with the calcium hydroxide, is equal to the total number of moles take away the total number of moles in excess. Once we've got that, if we know the moles that react with calcium hydroxide, this one here, if we know the moles that have reacted with the calcium hydroxide, we also know that because of the ratio, we've got 2 HCl's to a 1 calcium hydroxide, we know that the moles of CaOH is equal to half the number of moles of HCl reacting with the calcium hydroxide. And once we have the number of moles of HCl, we know that mass divided by the number of moles will give us the MR of the calcium hydroxide, and therefore we can recognise the solid. So that is one of our rules. So whenever you get a practical question, how are you going to do it? What scale are you going to use? And how will you lay out your results? And finally, how will you use these to calculate your answer? So what I've done here is we've outlined how immediately we can calculate the relative formula mass of the solid. The next thing that you've got to be careful with is what quantities are we going to use. They've left it up to us to decide on the concentration of the standard sodium hydroxide solution, but they've given us a hint. We're going to roughly know the maximum amount of moles of acid we've got because they've told us that the total number of moles, if we calculate that now, is equal to C times V over 1,000, which is equal to 0.2 times 50 over 1,000, which comes out to 0.01 moles. So that is the maximum amount of HCl before even any calcium hydroxide reacted. So we know that the concentration of sodium hydroxide that we're going to use is going to be less than 0.2 moles per dm cubed. So what you now need to do is decide practically how are you going to carry this out. Well, because you've got a fixed volume of hydrochloric acid, you've got 50 cm cubed, and the best thing to do here is a storyboard, which I'm going to do at the side. So in your beaker originally you had a mass of calcium hydroxide. You're then going to dissolve that in 50 cm cubed of hydrochloric acid. So you're going to have to titrate the mixture that's in this beaker. So for that reason, sodium hydroxide must go into the burette. We know here that to calculate the sodium hydroxide that's now in excess, because some of it's reacted with the calcium hydroxide, some's left over in excess, and we're going to have to titrate what's left over in excess. You know that sodium hydroxide and HCl react in a 1-to-1 ratio, and therefore, if we know the concentration of the sodium hydroxide, so say for argument's sake, we're going to use a 0.005 moles per dm cubed solution. We've got a fixed volume, so we know the titration volume, and therefore we can work out the number of moles of sodium hydroxide. The number of moles of sodium hydroxide that reacted with the with the hydrochloric acid now gives us this value here, the number of moles in excess. So we've got the number of moles of hydrochloric acid in total, we've got the moles in excess, and therefore we can work out the moles that have reacted with the calcium hydroxide. And now we can find the MR because we know the moles of calcium hydroxide is equal to half the number of moles reacting with because of the 2-to-1 ratio.